It turns out that I was completely wrong about Oumuamua, ladies and gentlemen. I'm very sorry about that. It turns out that it didn't slow down on approach to the sun at all. Rather, it slowed down as it was leaving the sun's gravity, as might be expected. However, the big controversy about Oumuamua was that it didn't slow down as much as they're anticipating it would slow down due to gravity. So they thought, some people thought that it was alien propulsion systems propelling it very slightly faster away from the sun when it should have been propelled, and various hypotheses have been leveled to try and explain why this is the case. With due to natural causes such as outgassing and solar radiation pressure, both of which have their own merits as ideas, I suppose. But no, in the quantum gravity theory that I advance, no, it wouldn't cause objects to slow down on approach to other objects. So the reason for this is because there is resistance created there in the gravitational fields of objects. However, the amount of resistance created is never enough to overpower the force of attraction, and the force of attraction is generated from the protons in a certain object approaching another object. They're attracted to the electrons in the gravitational field of another object. So as you get closer to the surface of, say, object 1, say object 1 is like a star or something, and object 2 is, say, Oumuamua, object 1 will have a cloud of electrons surrounding it, the density of which increases as you get to the surface of object 1. Get towards the surface of object 1, there's more electrons there, of course, due to, in accordance with Newton's inverse square law for gravity. In object 2, there's likewise a cloud of electrons surrounding it, which creates resistance between the two gravitational fields. However, the resistance is never enough to overpower the force of attraction, because half the electrons are always behind object 2, if you see what I mean. So that lessens the amount of resistance that can be created there. And there's always a greater amount of electrons from object 1 interacting with the protons in object 2. So you can see how there could never be a greater force of resistance ever to overpower the force of gravity, since half the electrons from object 2 or object 1, the smaller one, whichever it is, the Oumuamua one, those are always behind the object, and therefore creating a lesser force of resistance, or never creating as much resistance as you'd need to slow an object down in a gravitational field if it were approaching an object. So yes, I was completely wrong about that. In terms of the physics that I'm trying to develop, yeah, I was completely wrong on that level. So that was just a blunder of mine, I'm afraid to say. But nonetheless, it does tell us, well, it does. Oumuamua doesn't tell us anything about quantum gravity, unfortunately. But yeah, it was an interesting idea while it lasted, and it did lead me into more interesting considerations so far as it relates to my idea for quantum gravity. And crucially, I need to try and explain dark matter using this model. So this is all about how the rotation curves at the centers of galaxies, objects move more slowly around the centers of galaxies than they do at the extremities. The rotation curves are faster. They rotate faster at the extremities of galaxies than they do closer to the center, and this is thought to be due to dark matter. And there is still some electrical resistance created there between objects due to the electron clouds mutually interacting. So an electron cloud surrounding, say, a star at the extremities of the Milky Way, that will be rotating faster around the center of the Milky Way than a star closer to the center, because the star closer to the center simply has to move through this greater sea of electrons, this greater density of background particles, creating resistance there in the orbit between the electrons in each electron cloud. I've really probably butchered this explanation, but oh well, I'll just kind of carry on with it. I know it's very confusing for a lot of people. It's very hard for me to explain this in simple terms because it involves so many quantum mechanical effects, so many quantum field theoretic effects, so much which is on, well, like the bleeding edge of physics at the moment. And if you don't have a strong-ish physics background, you might get lost during this sort of video. I do totally understand that, but nonetheless, yeah, it's there is a force of resistance created between these mutually interacting electron clouds. So yeah, that still does explain dark matter, I'm afraid to say. Although it doesn't explain Oumuamua and its trajectory. And I was wrong to invoke that example. So I thought I'd just put this video out there now explaining that.